Hello, welcome to questions 50 through 55 on chapter 5. Question 50, for the function f of x equals the square root of 3x minus 2, find the value of each expression below. So we have f of 1, that means we will plug 1 in to the function. So we have f of 1 is equal to the square root of 3 times 1 minus 2. That's the square root of 3 minus 2, or the square root of 1, which is equal to 1. So f of 1 equals 1. When you plug 1 in, you get an output back of 1. B, same function, we're going to plug in 9 for x. So this would be 3 times 9 minus 2. That would be 27 minus 2, or the square root of 25, which is 5. So f of 9 is equal to 5. Part C, we have f of 4. F of 4 is equal to the square root of 3 times 4 minus 2. And f of 4 is equal to 12 minus 2. And 12 minus 2 is the square root of 10. It does not say to simplify if we can or round. Let's go ahead though. We could either leave it as f of 4 equals the square root of 10, or we can approximate the square root of 10 by plugging that into our calculators. And if we do that, we will get the value of approximately 3. I'll go to the nearest hundredth, 1/6. D, we have f of 0. So that would be the square root of 3 times 0 minus 2. And that would be 0 minus 2, which is the square root of negative 2. And that is undefined because we cannot take the square root of negative 2. F of 0 is undefined. And that has to do with your domain is not all real numbers, so there's only certain numbers that you can plug in to this function f of x equals the square root of 3x minus 2. And then on part E, it says what value of x makes f of x equals 6. So now f of x and 6 are equivalent. So we're going to replace f of x, which is our output, for 6. So 6 is equal to the square root of 3x minus 2. Now we could do this a couple of different ways. We could ask ourselves, what square root is going to give us 6? Well, that would be 36. So we could say, therefore, if that's the case, that 3x minus 2 has to equal 36. And we could solve that by adding 2 and then dividing by 3. So 38 thirds. And that would be one way to do it. The other way, if we solve using our inverse operation, since it is the square root, we can undo it by squaring both sides. And if we square 6, we get 36. And if we square a square root, they undo each other and they cancel each other out. And I'm left with 3x minus 2. Similar to what we did before, but before we were more just thinking about it. This way we're actually solving it using our inverse operations. Add 2, we get 38 equals 3x, divide by 3, and that would be 38 thirds again. And you could rewrite that as a mixed number if you wanted to. And that would be 12 would be 36. So 36 and then 2/3. So it would be 12 and 2/3. Either way is fine. But don't write it as a decimal because it would be a repeating decimal. So that's how you evaluate the function f of x equals the square root of 3x minus 2. Question 51, simplify each expression below. So on these, we're not plugging anything in for the variables. We are just combining like terms. So 1y plus 0.03y would be 1.03y. So just combining like terms. B, similar, z minus 0.2z. So that's 1z minus 0.2. That would be 0.8z. And then on C we have x, or 1x plus 0.002x, and that should be 1.002x. So on 51, we're just simplifying by combining our like terms. Really what this one is kind of helping you with is in front of the variable, if you don't see anything, it does have a coefficient of 1. Question 52, a tank contains 8,000 liters of water. Each day, half of the water in the tank is removed. How much water will be in the tank at the end of the 4th and then the 8th day? So we could do this a couple of different ways. One way to look at this is by creating a table. And at the initial time, we have 8,000 liters in the tank. And after the first day, you have half of that remaining, which is 4,000. After the second day, 2,000. Third day, 1,000. I'm just basically cutting each of these in half because half the water in the tank is removed. And so on the 4th day, it's 500 liters. So on part A, on the 4th day, the tank contains 500 liters. Now the 8th day, we got to keep going. So extend the table out. On day 5, you're at 250. Day 6, half of that is 125. And if we're going to keep the decimals, we're going to keep taking half. We are going to create decimals at this point. So we'll keep those. 62.5. And then 62.5, take half of that. That's going to give you 31.25. So on the 8th day, the tank contains 31.25 liters. Now that's one way to do it. Another way to look at this, potentially, is to look at what's going on in terms of taking half of something. So each time it's getting multiplied by 0.5. So if you look at it, the y value will be equal to 8,000 and then times 0.5 for each day. So it would be multiplied by 0.5 for day 1, day 2 again, day 3, and day 4, which really simplifies to 8,000 times 0.5 times itself 4 times. And so if you plug it in, you will get 500 liters. You could do the same thing for the 8th day, but it'd be 8,000 times 0.5 how many times? A total of 8 times. And if you plug that into your calculator, once again taking 0.5 and raising it to the 8th power, and then timesing it by 8,000, you will get the 31.25 liters. So you could kind of set it up as an equation looking for that repeated multiplication that we have talked about. Question 53, solve each system. So we're going back to Chapter 4 where we solve systems of equations using substitution elimination or the equal value method. On 53, it's not set up for substitution because you don't have a single variable to solve for, but you could easily solve for y in the first equation if we wanted to. We also could use elimination. The x's and y's are all on one side. They're just in a different order, but we can rewrite this as 3x plus y equals negative 10, and then leave the second one alone, 3x minus y equals 2. And now when we add them, you can see that the y's will eliminate without multiplying the equation by anything. So once again, either way, you could solve this by substitution or elimination. You get x equals negative 1, and then you can plug that back into either equation. I'll go ahead and plug it back into the first one. And we get y minus 3 equals negative 10. Add 3 to both sides and get negative 7. So the solution, and remember to write this as an ordered pair, since it's just a generic problem. When it's on application, we're not solving specifically for a certain label. So write it as an ordered pair, negative 1, comma, negative 7. It doesn't say check our answers, but we could do that by plugging it back in to the original two equations. On B, Once again, it's not set up for substitution. You don't have a variable solve for. It's not also set up for elimination because you have the x's and y's on this side, but on this one, the x and the y's are on different sides. So we have a choice here what we want to do. Since I solved the first one using elimination, I'll solve this one using substitution because there is a y here that we can easily solve for. So I will subtract the 4x to both sides and get y equals negative 4x plus 4. And now I will take that expression and plug it back into the other equation, the first equation, and I get 6x equals 7 minus 2 times negative 4x plus 4. So I substituted negative 4x plus 4 in for y. Now we're going to distribute 7 plus negative 2 times negative 4 is positive 8x. Negative 2 times positive 4 is negative 8. Subtract 8x to both sides. That'll give me negative 2x, and then 7 minus 8 is negative 1. Divide by negative 2, and x is equal to 1/2. And then now we can go and plug this back into either one of the equations. I'll plug it into the, well, since I solved for y, I'm actually going to go plug it into this one right here that we solved for y. So this will be y equals negative 4 times 1/2 plus 4. So that would be negative 2 plus 4, and that is 2. So the solution is 1/2 comma 2. Once again, we don't have to check it, but we could plug it back in to check it. Question 54. Draw a slope triangle and use it to find the equation of the line shown in the graph below. Now we need two things. We need the y-intercept and we need the slope. So we can use the slope triangle right here to identify what the slope is. The graph is going from 2 to 4, so that's a change of 2 units. And then the y is going from 130 to 150, or 150 to 130, and that's a difference of 20 units. Now, the line is going down, so we could look at this as being a negative 20. So the slope would be negative 20 over 2, which is negative 10. Now, the y-intercept looks like it might cross about 175, potentially, unless it looks like actually it's going by 10. So 10, 20, 30, 40, 50. So it is going up by 10, so that'd be 160, 170. So therefore, with the y-intercept being at 170, our equation is y equals negative 10x plus 170. Now, if it didn't intersect nicely on the y-intercept, we could use the slope that we found using the triangle and a point to be able to find the y-intercept exactly. And the last question, 55. This problem is a checkpoint for laws of exponents in scientific notation. It will be referred to as checkpoint 5A. So we have 6 different questions here dealing with the laws of exponents that we have been practicing and the scientific notation. Simplify each expression. In parts E through F, write the final answer in scientific form. So we'll go ahead and start with question A. We have 4 to the second times 4 to the fifth. Now we could take 4 to the second and get 16, and then 4 to the fifth and get whatever that is, and then multiply those two together. But because they have the same base of 4, we keep the base and we add the exponent. So that'd be 4 to the 7th power. 4 to the 7th power is not one that we know off the top of our head. If we wanted to get the exact value in terms of expanding it out, it would be 16,384. But I would take 4 to the 7th power on that one without the calculator. B, we have 5 to the 0 power raised to the third. Could do this a couple of ways. 5 to the 0 is 1, so 1 to the third is 1. You also can multiply the exponents and get 5 to the 0, which is also 1. So a couple different ways you could look at that one. C, we have x to the negative fifth times x to the third. So we can add the exponents, and so when we add negative 5 and 3, we get negative 2. We cannot have any negative exponents, so we're going to rewrite this. Remember, think reciprocal with the negative exponent, so 1 over x squared. D, we have x to the negative 1 times y to the second raised to the third power. On this one, we have a power raised to another power, so we can multiply. So this would be x to the negative third and y to the positive 6, and then once again, the negative 3, x to the negative 3, can be moved to the denominator, but the y to the 6, since it's a positive, we keep it in the numerator. On part E, we're multiplying two numbers that are in scientific form, so we can take the 8 times the 1.6 and get 12.8 times 10 to the, and then we add the exponent, so 5 and negative 2 is 3. Now that's not quite in scientific form because this number has to be between 1 and 10. It has to be a single digit in terms of the decimal point, so we want to move the decimal point over to the left to 1.28 times 10 to the, and since that's 12 is bigger than 10, we're going to move the decimal point one place, so that would be 10 to the 4th power. So 1.28 times 10 to the 4th power is the number written in scientific form correctly. And then on F, we got 4 times 10 to the 3rd divided by 5 times 10 to the 5th. So 4 divided by 5 is 0.8. And then since we're dividing, we subtract the exponents. 3 minus 5 is negative 2. And with scientific form, we don't care about the negative exponents. That's fine. But we do need to move this decimal point to the right one. So now that's a number less than 1. So it's 8.0 or just 8. Times 10 to the, and we need to subtract 1 since we moved it to the right 1 unit, and the number was small, and we moved it to the right and got 8, so it's 8.0 or just 8 times 10 to the negative 3rd power. So at this point it is a checkpoint. These are things that we should be able to feel pretty comfortable doing at this point in time.